So in today's video, I'm going to answer this problem right here. I'm given a circle of radius r, and inside that circle is inscribed an equilateral triangle of side length x. And the problem asks for you to find the circumference of our circles, C, as a function of x, the side length of the equilateral triangle. So the way I'm going to approach this problem is I'm going to find the area of the red triangle in two ways, and then I'm going to equate those and see if I can use that then to find the circumference as a function of x. So we know that the circumference of a circle as a function of r, as a function of the radius, is 2 pi r. And so my method of attack, as it were, is that I'm going to replace r here with x. That's what I want to do. And so what I really want is I want to find the radius r as a function of x. If I can find the radius as a function of x, I can simply input that value in here. And then I will have, instead of having circumference as a function of r, I will then have this function of the circumference as a function of x, which is what I want. Okay, so I want to find the area of the red triangle in two ways. Here's the first way. Probably the most obvious, I'm going to take the area of the triangle is 1/2 base times height. Okay, so I take my red triangle, the area of that triangle is going to be 1/2 base times height. Well, the base is straightforward. The base of my right triangle is at x. The height of my red triangle, well, let me just do a little bit of geometry just here for a second. My red triangle is like so. This height here is what I'm looking for, h. I have here a right triangle. We know that this length here is x. And we know that the distance from here to here is going to be x over 2. So let's be x over 2. So to find that h, I'm going to use the Pythagorean theorem. That would tell me that h squared plus x over 2 squared is equal to x squared. The hypotenuse squared is equal to the sum of the square of the other two sides. Working this out then, for h, I have that h squared is equal to, on this side I have an x squared. Here I have x over 2 squared, which is x squared over 4, and I'm going to subtract that to the right hand side. So it's going to become minus x squared over 4. And so I have that h squared, x squared minus order x squared is 3/4 x squared, 3x squared over 4 if you like. And so therefore h is going to be the square root of this. I'm going to take the positive value for the square root of length, and so it's going to be the square root of 3x squared over 4, and that's the same as the square root of 3 times the square root of x squared. Well, the square root of x squared is x, all over the square root of 4. The square root of 4 is 2, and so this will be root 3x over 2, or root 3 over 2x. And so that is my h right here, and I can put in this value here for h. So this will be, instead of h, I have root 3 over 2x. I'll put parentheses around that. And so the area of my red triangle as a function of x is 1 times root 3 is root 3, 2 times 2 is 4, x times x is x squared. So the area of my red triangle as a function of x is root 3 over 4 x squared. Okay, so I can leave that right now. It's my sort of my first equation for the area of my red triangle. And now I'm going to find it in a different way. So here's what I'm going to do. I'm just going to erase this. I now notice that if I could find the area of this triangle right here, that is exactly 1/3 of the area of the red triangle. So this triangle right here is 1/3 of the red triangle. So can I come up with an expression for the area of this triangle? If I can, if I multiply it by 3, then that will be equal to the area of my red triangle. Okay, so the area of this triangle here then, so this is the area of my smaller little dark triangle right there, is going to be 1/2, of course it's 1/2 base times height, again. That is 1/2, well my base is again x. My height, what is my height here? Well again, I'm just going to do what I did before. I'm going to take out that triangle. I'm going to see if I can work out h. So here's that triangle. And this here is h. Again, this side length here, or this if you like, this is going to be x. And so this here will be x over 2. From here to here will be x over 2. Forgive my poor drawing skills. This side length here is this side length here, and that's r. That is r. And so to work out h, I'm going to use the Pythagorean theorem. I've dropped a perpendicular, so that's a right angle. And so I have that h squared plus x over 2 squared is equal to r squared. Working this out, I have, this is h squared, this is x squared over 4, this is r squared. Subtracting my x squared over 4 to the other side, I get h squared is equal to r squared minus x squared over 4. And taking the positive square root, I have then that h is equal to the square root of r squared minus x squared over 4. And so I can put this in here for h. This will be 1/2 base times height becomes 1/2 x times the square root of r squared minus x squared over 4. I probably don't really need that parentheses, so I'll just take that out of there. And so that is the area of this triangle. And now I know that the area of my red triangle is 3 times this. That is, the area of my red triangle is equal to 3 times the area of my smaller black triangle right there. And so I'm going to multiply this by 3, and I'm going to equate it with this. What I find then, let me just erase this, is that root 3 over 4x squared, which is this, root 3 over 4x squared is equal to 3 times the area of my smaller triangle, so that's 3 times this. Well, 3 times 1/2 is 3 over 2. So that would be 3 over 2 times x times the square root of r squared minus x squared over 4. And now what I want to do is I want to, of course, think back to where my original problem. I want to find c in terms of x. I know c in terms of r, and so I want to find r in terms of x so that I can substitute it in here. Here I have x's and r's, and so what I want to do is I want to solve for r. I want to isolate r. Well, the first thing I notice is that I can cancel out one of my x's, left and right. I know that x is not 0, so because it is the side of the triangle, so I'm happy enough to cancel that. And that leaves me with root 3 over 4x is equal to 3 over 2 times the square root of r squared minus x squared over 4. Again, I want to take out my r, but it's underneath that square root sign. So what I'm going to have to do is I'm going to have to square both sides. Square both sides. So that will give me then, squaring the left-hand side, what I'm going to do, just to be clear, I'm going to square this, and I'm going to square this side. Root 3 over 4x squared is root 3 squared is 3 4 squared is 16. X squared is x squared. That's will be equal to square root of this. 3 over 2 squared is 9 over 4. Times the square root of r squared minus x squared over 4 is r squared minus x squared over 4. Okay, I may as well distribute in my 9 over 4. That will give me 3 over 16 x squared is equal to 9 over 4, so it's 9r squared over 4 minus 9x squared over 16. Almost there. I will bring my 9x squared, my negative 9x squared over 16 to the left-hand side, and so I will have 3 over 16 x squared plus 9x squared over 16 is equal to 9r squared over 4 on algebra. Adding these two together, I get 3 and 9, that's 12 over 16. 12 over 16, yep. So I get 12x squared over 16 is equal to 9r squared over 4. 12 over 16 is 3 over 4, so I really have 3x squared over 4, which is 9r squared over 4. And so, finally, to isolate my r squared, I will divide both sides of this equation by 9 over 4. Division by 9 over 4 is the same as multiplication by 4 over 9. And so, I get that r squared is equal to 3x squared over 4 times 4 over 9. Times 4 over 9. And so r squared is equal to, I lose a 4 above and below, and I have 3x squared over 9, which is x squared over 3. And so I have that r squared is actually equal to x squared over 3. I want r, and so r will be the square root of this. That is to say, r will be the square root of x squared over 3. And again, I take the positive square root. And that is the same as x over root 3. And now I can take this value and I can substitute it in to my circumference. And I can replace r with my circumference as a function of r with x. And so my circumference, again, I know that c of r is 2 pi r. Well then c of x will be, instead of 2 pi r, I have 2 pi, and I can replace r with x over root 3. Root 3. And so, just tidying up, I have the circumference as a function of x is 2 pi over root 3 times x. Now, typically, we wouldn't like to leave a square root sign in the denominator. So what I'll do is I'll multiply this equation here above and below by root 3. And so that will give me the circumference as a function of x is 2 pi root 3 over 3 times x. 2 pi root 3 over 3 times x. Again, all I have done to go from here to here is I've multiplied above and below by root 3. And that is it. That is my circumference of my circle right here as a function of x, the side length of my triangle. And that's how you go about solving that problem.